I will do an example related G+3 story design in eTABs software. So as per my experience, eTABs compared to STAAD Pro is quite more efficient, quite more in detailed software, and it can give a better result regarding this G+3 story design. So let's crack it. This is first step to go towards it. Now I will discuss the steps regarding it, so we will get the idea of what we are going through. So first of all, we will make a grid according to the plan which we have to analyze. So making grid like this, then naming the section material. So there are basically three section materials that I want to design, that is beam, column and slab. We have to design its beam thickness, the breadth, the depth, the reinforcement required in it, the cover required, all the details we have to enter in it, so as to get this going. Now again for column and same for the slab. Then we will assign this given section into the grid. So we have designed this, we have defined this material section. Now we will assign this. We will give this grid the dimension and what is beam, what is column, what is slab. We will give it to them. The next is naming the load cases and giving the values. So there are basically 4 loads that will be acting. We will be acting on it: dead load, live load, seismic load, and wind load. So dead load. What dead load consists? Dead load will be acting dead load on whole structure first initially. Then we will act through beam, then column and slab. What will be acting on beam, column and slab is that the self rate, that is B into D into density. Then on live load acts only on slab, so we will act only on slab. Seismic loads consist of 2 direction. Now EX and EY. What is EX? EX is earthquake load. Seismic load is nothing but an earthquake load acting on X direction and acting on Y direction. Same goes with the wind load, WX and WY. Now assign fixed support to the base. As we saw in the STAAD Pro as well, to assign the fixed support to the base, and we will run analysis. First of all, we check the shear force and bending moment diagram, the axial diagram, the various deflection as animation, and we'll check the analysis, and then we will design the detailing with this. So this is the plan that I want to design here. So it is a line diagram, so don't worry about this, not clearly defined as well. So this is the base here, 1 2 3. The X direction has 3 base, and so as Y direction has 3, but there the spacing between is quite different: 4 6 4, that is meter, and 3 3 3 here. So without wasting any time, we will go to further through the eTABs software. Go to file, go to new model, use built-in settings with track this thing: display unit metric SI, steel section Indian, steel design code IS 800 and concrete design code IS 456 2000. Click OK. Now we will create this type of structure here in this eTABs software. So the number of grid lines in X direction are this: 1 2 3 4. So 4 are this in X direction, so we will write 4 here. The Y direction also 4. The spacing between the, initially we will write 4, this is 3. Use custom grid settings, edit grid data. Here we will edit this. The first is 4, the second is at 10, the third is at 4. So this is the whole structure will look like. This is also 369. Click on OK. Use grid only. Click on OK. So now wait for the model to be appear on the screen. So this is the model we were designed. The rightmost window indicates the 3D view of this model. The middle window indicates the plan view of this model, and the last right side window, it indicates the model explorer, that indicates the reports and detailing of this software that we will design. So the first step will be to define the materials. What are the materials? Define, go to material properties, add new material, select region India, material type concrete, use Indian code, use code whichever you want. I am using M25 grade here. M25, choose modify show data. Okay. Now this is concrete data. Okay. You use new new material, use Indian code. Now use steel material. Initially you click OK, then change it to FE415. If you want to change for FE 550 or 500, you can choose it. What we will do is modify this thing and change the strength F5 strength into F415, and this also the first two is to change 415. Click on OK. Click on OK. So the materials are assigned. Now we will to assign these three section properties, that is beam, column and slab. So first of all we will go to define, go to section properties and go to frame section. So initially we will delete this all properties here. Now add new property, click on concrete. So first of all we will rename it as beam 0.25 cross 0.40. This is the size I want to design the beam, 0.25 into 40. So write this depth 400 and width 250. Changing the material type as M25. Show section properties. This is the section properties. Modify show rebar. Now use this beam type. Longitudinal bar are of, choose this add material FE415. Okay, longitudinal bar of FE415. This is also FE415. So if you want to change the cover, I want to change the cover on both sides, that is 50-50 mm, the effective cover. Click OK. Click OK. Now add new property. Choose again the concrete one, the rectangular size, and rename it as column 0.40 cross by 0.40. Show this material as M25. Sorry. Change this depth to 400 by 400. Modify show rebar size. Click on column. Now what we will do is clear confine to confinement. Now this is all the data we want to check and we want to change. We can change longitudinal bar size. I want to write 16 and corner bar size I want to write 18. The confinement bars I want to give 8. All the things should be checked. Click on OK. Click on OK. Now I will go to OK. Now we will go to select the slab section. So section properties, go to section slab section, add new property, write slab 125, that is 125 mm. Choose M25 grade, change the thickness to 125. Click on OK. Delete this. OK. So the properties are been assigned. Selected. Now we have to assign these properties into this model. So what we will do is choose this thing, quick draw beams, which is to choose the type or the property here what we want to choose, that is we want to design beam. So what we will do, the beam is being selected on the cursor. Now we will assign to it by creating this thing and then we will release it. Choose all story here, again do it for the all stories. So the all stories are been assigned for the beam. What will go now to change this quick draw column, change this property to column, again drag it to the whole structure, all the columns will be assigned. Now choose this quick draw floor, change this deck 1 to the slab that we have assigned, select all and release. All the slab section properties will be assigned. What we will do, that the slabs is also assigned on the base floor, so we want to remove this base floor. Select this one story, and go with this cursor. We will go to base story. How we check in base story? This is this side, left hand side. We write in plan view on base. So we'll select this thing and click on delete. So the base slab is been deleted. There is no use of base slab. So this is the structure we have occupied. Now we will go to view, go to set display option, set display option, extrude frames and extrude shell. Click on apply, click on OK. So this is how the structure looks like. Check if there any mistake happens in between while assigning. So now the most important part of this assigning thing is the load value. So what we will do is assign load. So there are 4 load cases that I have already told you. Define, go to define, go to load patterns. So there is already dead load and live load present here. So we will add EX and EY. EX is what? Seismic load. Change the code to IS 1893-2002. Click add new load. Again EY, add. Now for the wind load, WX, change this type to wind load. Now this wind load is IS 875-1987. Add new load. Again for WY, add. What we will do is now click on EX and modify lateral load. So it is in direction X. So deselect all this term and only select this X direction. So as per this code, the factors that are given, that is seismic coefficient as Z is 0.36. If you want to change it, please change it. Site type is 2, that is medium. Important factor 1. Click on OK. For EY, do it same, but this time we will deselect all this pattern and only select this Y direction. Remain same. OK. WX, modify lateral load. What we'll do is change this wind speed according to the city that this building is being constructed. If my building is constructed in Bhuj, that is 44, or that Ahmedabad or Surat, anyone you want to change. The terrain category, structure, risk, structural class, that is B, that is medium class, risk coefficient, topography, all we want to change, please change it. Modify this X value to be 0. OK. Click on WY. Same goes with this thing. Now for Y direction, I will change this degree to 90. Click on OK. Click on OK. Now all these properties of these load patterns are being assigned. We will now assign this load to the given structure. First of all, we'll do the load with starting of dead load. Now dead load is applied to the whole structure first. So what we'll do, go for assign, go to joint load, go to forces, dead load. Now we'll assign this 1 kilonewton on whole, this values. Go to add existing load. Remember to add this part in every adding load. Click on apply. Click on we have to select the whole structure. Select Ctrl plus A. The whole structure is selected. Now go to assign, joint load, forces, add to existing load. Select this 1, apply, OK. So now the dead load is applied on all the parts. Now what we will do is the dead load coming to beam, column and slab. So first of all, we assign to beam. So what we'll do, we have to select beam first of all. Select, go to properties, go to frame section, select beam, select. So all the beams in this structure has been selected. Go to assign, go to frame loads, go to distribution load. Now change this thing. What we will change is the dimension of beams, that is 0.25 multiplied by 0.40 and multiplied by density of concrete, that is 25, that is 2.5. So we will give this load to be 2.5 kilonewton per meter. Add to existing load. Click on apply. click on close. Now we'll select column, click on select. So column has been selected. Now go to assign, go to same frame load, go to distributed load, click here, and we will to change this dimension. What is the column dimension? It is 0.4 by 0.4. That is the column dimension we have already selected into 25. That is 4 kilo. Add to existing load, click on apply, click on OK. Now what we will do here is to assign this thing to the slab portion. So select slab portion by selecting properties, go to slab section, go to slab, click on select. So go to assign, go to shell load, click on slab section, go to assign, go to shell loads, uniform, click on this load, and what we will do is the breadth of the beam, that is 0.125 meter into 25, 3.125 is the load acting on the shell. Click to existing load, click on apply, click on OK. So the dead load is applied. Now we will select for live load. So give to select the live load be acting on slab. So select slab section, select assign, go to shell load again, uniform. Now here choose the load pattern as live, and we will assume the live load coming is 4 kN per meter square. Add to existing load, click on apply, OK. Now what we will do is close this tab and select Ctrl plus A. Let me just give you this idea, that is Ctrl plus A, the whole structure has been selected. So now we'll go to assign, go to frame loads, go to distributed load, go to assign, go to shell loads, go to uniform load, that is the first one, EX, that is earthquake in X direction. The earthquake load is half, that is 50% of live load, that is 4 kN, 2 kN per meter square. Add to existing load. Now in X direction, earthquake in X direction, global X, click on apply, click on OK. Now that is applied. Now again Ctrl plus A, go to assign again, go to shell load, uniform. Now EY in global Y direction, 2 kN per meter square. Add to existing load, click on apply, OK. Now what we will do is for wind load, again Ctrl plus A, assign, shell load. Now what we will go is wind pressure coefficients, WX, the wind pressure coefficient we will assume 0.8, click on apply, OK. Again Ctrl plus A, assign, shell loads, wind pressure coefficient in Y direction 0.86, apply, OK. So all the loads have been applied. Now what we'll do is to give this building a support. So how we will go to support? Now go to the base by using this arrow. I am on the base. Now what I'll do is select this whole base thing, go to assign, go to joints, go to restraints. Now select this fast restraint, that is the fixed one, click on apply, OK. The beam is the column foundation has been assigned with fixed supports. So what we will do now is to analysis and check the model. Go to analysis and check, tick these 3 ticks, OK. The model has been checked, no warning message has been generated. So the model has been checked, and now there is no thing like warning here. So we will go to analyze and run this analyze. So change this thing and rename as whatever you want to. Now I am going to G+3. In whatever file you want to save it. So now the analysis will run and it will take some amount of time to get through this, and the whole building is being designed. So let's wait. Now this is the deflection diagram of this building. So the analysis has been done. Now this is the deflection diagram. Now what we'll do is go to display, go to deform shape. So we will use this thing as the animation progresses. Use start animation. So this is the animation, that is the displacement by the dead load acting. Change this to live load, click on apply, go to start animation again. This is the animation regarding the live load. So you can select any one of these, EX, EY, wind load. Let me just give you idea of WX, apply. Go to start animation. That is wind load, that is no effect of wind load on this building. Click on close. Now what we will go is for again go to display, go to force stress diagrams, and we will check this force frame diagrams. Go to axial force, click on apply. So this is axial force diagram. Shear 2 means shear in x direction, shear 3 means shear in y direction. Bending moment diagram in x direction and in y direction. This is all things again for live load. This is again a different thing. Okay, go to display and deform shape. So now what we will do is go to design and design this structure to concrete frame design. View revised preferences. This is the preferences you want to check. If you want to check, click OK. Go to design, concrete frame, rebar section rules. For the seismic rolls, we want to change this rebar thing to 12 and largest bar size to be 16. If you want to change this, 8. OK. Again go to design, concrete design, rebar section rules for beam. What I will choose is this. I will choose this 12 and 12. 8. Minimum spacing, I want to reduce the minimum spacing here, 300. So as for here also, click OK. Now what will go for design, concrete design frame, start design check. So it will design this building and it will give you necessary outputs regarding it. It will take some amount of time based upon your computer preferences. So design has been done. What will go for detailing now? Detailing preferences. Okay. Go to detailing again. Go to start detailing. This is the most important step. If your design has been completed, analysis is completed, go to design. Now what is this? It will give the full idea of what is been designed. It is the floor planning plan, that is a column, beam and section plan. Go to detailing, drawing, go to standard details, list of drawing. This is a list of drawing that has been created. Typical concrete beam elevation. This is the whole continuous beam designed by this software. You can see the spacing also. This is the column from first to the fourth floor, third floor. This is a slab thing. The slab section. Beam details. This is the most important thing. The beam and column, this concrete rebar method table is the most important thing used in the site. This is cage view. This is interesting. Check this beam cage view. Now this is the 3D structure of how the beam looks like and how the spacing of this thing has been done. Now what we'll go to report. Now you can check all of this thing and get reports of it. Go to project reports, double click on it. It will generate a report regarding this building in some amount of time. So the building report has been completed. Now look at this. It has created numerous tables, files, and this whole structural data 154 page. So you can print out like this. So this is very important that everything has been done by this software easily and quite effectively in some amount of time. That is very good for a structural engineer to do some amount of time. Based upon my experience, I have noticed that STAAD Pro VATI software is not that up to the mark that eTABs have given us option about it. So if it is your choice to what you want to design. So there is also video available on G+3 multi-story building on STAAD Pro VATI software that I have uploaded. So please do check it out. Also there is video of cantilever retaining wall, so you can check it out as well. And please subscribe and like this channel. Thank you.